Okay, this video is for Mrs. Cucci's College Now Pre-Calculus class. We left off on lesson 3.2. We got to we finished 1.8. We finished graphing this polynomial. Now, we do have to continue on with the lesson, and this is a redo video because the last video came out blurry. So you should have lesson 3.2 open, and I'd like you on page 1.9 or on this polynomial here. Okay, so again, we're going through and we're graphing these polynomial functions, and we're running through those 5 steps and getting all of the information we need. And we know that it is a lengthy procedure, but the procedure itself isn't difficult. It's just longer than it would normally take. Okay, so what we're going to do is we're going to graph this last one, and then we're going to talk about the intermediate value theorem, which shouldn't take long. Okay, so we have my function right here, and it was very nice to you, and it is already in factor form for you. Okay, so we're going to start by talking about that leading term, right? Our step one is to talk about my leading term test. Okay, so my leading term test, what we're going to do is we're going to look at the leading coefficient, which we know is a positive 1, and then my exponent, which is even. Okay, so because the leading coefficient is positive and the exponent is even, I know on my end behavior as x approaches negative infinity, my function is going to approach positive infinity. And as x approaches positive infinity, my function is also going to approach positive infinity. So there's my leading term test. Okay, and I'm going to work this way and then down to the next page. Step number 2 is to then find the zeros. Okay, and again, since it's already in factored form for you, we've made this much easier. Okay, and since it says squared, we can write that twice. It's already in factored form, so all I'm doing is I'm taking it, I'm setting it equal to 0, and then very quickly I can go through and find my zeros. Now I know that I had this twice, and we remember that because it shows up twice, I'm only going to write my solution once, but what happens is this has a multiplicity of 2. Okay, so that's just a little review. Okay, everything else here has a multiplicity of 1. So what that does is this gives us our zeros. -1, 0, 2, 0, and 4, 0. So now I already have a couple of points that I know I'm going to be working with. Step 3 is to deal with my intervals, right? Building those intervals, coming up with my number line, and finding where my function is positive or negative above or below the x-axis. The values that go on to this number line here are my zeros. Okay, so I've got the interval from negative infinity to -1, -1 to 2, 2 to 4, and then again from 4 to infinity. So I'm going to have to do 4 test points, one here, 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 and here. Okay, so we're going to deal with our first test value, our test point. And the first test point I want to do, TP stands for test point, is, let's say, -1.25. Okay, it's about here. So what I'm going to do is I'm going to take it and I'm going to plug that right into my function using my calculator. And I'm going to get a value of about 13.9. Okay, so what I've done is I've created another point for us to use a little bit later on when we get to graphing. Okay, so because I got a positive value, that means my function is positive here. It's above the x-axis. My next point in between -1 and 2, let's say we use 1. 1 seems like a nice one. So when I find g of 1, when I plug it into my function up here, okay, what I find is it's -6. So my function is below the x-axis between -1 and 2. Now I need a value between 2 and 4, nice easy one. Let's try 3. So when I plug 3 in, we get 3 plus 1 is 4. 3 minus 2 is 1 squared, which is 1. 4 times 1 is 4. And then 3 minus 4 is negative 1. So we get a nice easy value of negative 4. So my function is also below the x-axis here. And then one last one, let's try 4.25. And again, all I'm doing is I can store x as 4.25, and then I type this into my calculator, and I get a value of approximately 6.6. Okay, so since my value is positive, I'm above the x-axis on this interval. And today I'm not. Okay, so step 4 is to go ahead and find your y-intercept. Okay, and your y-intercept is actually very easy to find. It's just finding the g of 0. Okay, where x is equal to 0, you find your x-intercept. And just by looking at this, we know that everything here becomes 0, which leaves us with negative 16. So there's another point that we can use when we're graphing. Okay. Okay, so now we have a whole bunch of points that we can use. What we're going to do is we're going to find a couple of more points that might make sense for us. So I'm going to just highlight the points that we do have so that they're easier for us to come back and find. Okay. So my next step is to go ahead and we're going to graph this out. This, of course, is my last step.
Kayla, you got lunch.
Last time was 24. I came Tuesday.
Well, you said you didn't show up.
I was there Tuesday, and then
Okay, so we're going to go ahead and plot some of these points. You always want to start by putting your zeros in. It's usually a good idea. Okay, so we've got the point negative 1, 0. We've got the point 2, 0 and 4, 0. Okay. We know from our end behavior that we are going to be going up to positive infinity on this side. Okay, and as well on this side. So, based on this, we're above the x-axis, so we know we're going to be coming down to my 0. And then we do go below. Now, here's the issue. I don't have any information in between negative 1 and 2. So I need to find some information there. That's where that extra kind of piece of information comes into play. Okay? So there's your step number 5, is finding those extra values. So my suggestion here is to look at negative 0.5. We know what 0 is. That was our y-intercept, right? That's down here. So chances are it's going to go somewhere in between. And if we plug that in to our calculators, we do find it's negative 14.1. So it's like here. Okay. So this is going to come down. Oops. I know it's not very pretty. Sorry. Okay. And then we want to know what happens in between 0 and 2. There's too much space there, so let's take a peek at 0.5. When we plug 0.5 into our calculator, we get about negative 11.8. And then also probably 1. We found 1, negative 6. Okay, so that's going to come up to here. Now, it says that it stays negative. It doesn't bounce up, so this is going to come back down somewhere in here, okay? So we need to figure out what's going on between 2 and 4. So we did find the value 3, negative 4, so we can put that in. All right. So we know that it's going to come down. But let's also look at 3.5. We're going to find that that's at negative 5.1. So this actually does come down a little bit more before it pops back up. And then 4.25 we found to be 6.6. So somewhere here. So this is going to come back up and it's going to strike up. Okay. So although it's not the prettiest function, it does do what we thought it would do. Our end behavior is correct. It spikes up as x approaches negative infinity. It spikes up to positive infinity. As x approaches positive infinity, it spikes up to positive infinity. So although, like I said, it's not pretty, it does work the way we thought it would. Okay, so that's the last polynomial we're going to graph. The next thing I want to take a peek at is something called the intermediate value theorem. Basically, what the intermediate value theorem says is for any polynomial, say p of x, with real coefficients, and we're going to say that a can't equal b, if I have p of a and p of b, so I'm inserting some number a and some number b, if those two values, when I get them out at the end, have opposite signs, one's positive, one negative, then the function has a real zero in between a and b. So essentially what I'm saying is, if I have that, if that's the case, or it changes signs, that means that it's going to cross the x-axis in between those values of a and b. Okay? So the intermediate value theorem can't be used to determine whether there's a real zero between a and b if it has the same sign. So this only works when the signs are opposite, positive or negative. All right, so using intermediate value theorem, determine if possible whether the function has a real zero between a and b. All right, so we've got our a, we've got our b. So all we're going to do is we're going to plug those in, okay? We're going to find f of a, which is negative 4. We're going to plug that value in. And we're going to see what we get. And when we plug that in, you could put it right in your calculator and store if you'd like. We wind up getting negative 24. Okay. And the next thing we're going to do is find f of b. B in this case is negative 2. So again, we plug that in. And when we plug that in, we get a value of 8. That was strange. Okay. So since this has a negative and this is positive, that means we are going to have a real zero in between negative 4 and negative 2. Okay. So in between here and here, negative 4 and negative 2, this is going to cross somewhere. All right, that's what that means. Okay, so using the intermediate value theorem, we're going to try this next one, and we're going to see if this works. And I'm going to do it on a different page because this page does not like me for some reason. Okay, so we have our value of a, we have our value of b, so our first step is to find or evaluate the function at those values. Okay, so this gives us a negative 1 plus 1 plus 6, which gives us a positive 6. Now we're going to find f of 3. Which gives us 27 plus 9 minus 18, or 27 minus 9, which is 18. Okay. Since these are both positives, we cannot say that there is a real zero in between the value of negative 1 and 3. Okay. Okay, so let's try another. Okay, so we're going to find g of negative 1/2 to start. And that gives us the value of 7/48. G of positive 1/2. Oops. Sorry about that. I lost my negative signs. Gives us a value of negative 5/48. So since we went from a positive to a negative, we can say that there is a real zero between negative 1/2 and 1/2. Okay, so hopefully you guys understand how this intermediate value theorem works. It's pretty simple, and we'll do this last example in class before the beginning of class tomorrow. Okay, so if you have any questions, please make sure you bring them with you, and I will see you guys tomorrow. Bye.